So, it's 2:35. I guess we can sort of start. If I ask, is everybody here, you will say yes, of course, because there's a selection bias. So, welcome to this first session of the afternoon. I hope you enjoyed the lunch, and I hope even more that you will enjoy the seminar. But usually, if you don't enjoy the lunch, then you're not going to enjoy seminars as well. We'll talk about PostgreSQL security, and this is actually a workshop, not a talk. What does it mean? It simply means that it runs for double the time, but you're not required to do anything. So it's like a double talk. And because of this, I was sort of thinking to put a little break in the middle. So you have the possibility to disappear without shaming, or to invite other people, or to simply use the facilities for various reasons. We will cover more or less the following topics about Postgres. They're all related to security. We'll not talk about every aspect of security. I mean, security, it depends on the environment as well. And if the operating system is not secure, then there's very little that the software can do. If somebody else can copy the data files and look at the data files, there will be no security to stop from that. If the data files were encrypted, there will still be some decryption key somewhere, unless the administrator manually puts the decryption key every time there is a restart. So I'll talk of security relative to the fact that the server is secure. Also because you probably have other places and other ways to secure your server intended as a Linux machine. So assuming that your Linux machine is secure, what you have to do to make your database installation secure? Not only what you have to do, I think the point here is what can Postgres do for you? Because I'm assuming that if you're here, you're interested in Postgres a little bit, otherwise you will be somewhere else. But it doesn't mean that you're already using Postgres in production. And in fact, I'd like to ask a question. How many of you are already using Postgres? Practically almost everybody. Good and bad at the same time, because maybe somebody was thinking, I'm not using Postgres, but it will be useful for me. Let's see how secure it is. Anyway, we'll talk about these various parts of the security. Roles you will know already, but role level security you may not know or may know, depending on what your use case is. Auditing, you will have to know, because you have to audit your application, depending on what you do. I mean, sometimes it's difficult to escape auditing because you treat financial data, and so there must be some auditing by law. In some other cases, you only have auditing if the company you work for it's important. And finally, we'll have a few words about how to secure your application, okay? So these are the main 4 topics of this conversation. As my colleague Thomas said before, if you have questions, ask them the moment they come to your mind. Don't save them for later, because then everybody has to remember what we were talking about before. Don't worry about interrupting me. If I don't want to be interrupted, I'll pretend I didn't hear your question, so you will have to say, hey. Or if I like to be interrupted, I will restart easily. So who is me? That's my name. I work at Second Quadrant at the head of professional services. I'm one of the authors of that book, and also of the other books that are less relevant, like the Postgres 10 administration cookbook, the Postgres 9.6, and so on. But now, this is the latest Postgres, so you should have this one. You can also use other Postgres versions. Every version of Postgres lives for 5 years. So it's perfectly fine to use 9.6 or 9.5 today. If you use 9.4, it's also fine, but you have to know that it goes end of life in December. So you probably have to be prepared for upgrade. If your use case is lucky, upgrade is very easy. You can do it in an afternoon, or even in very, very quickly. If you have a more complicated use case, it may take a little longer to upgrade. All the PostgreSQL major versions are incompatible with each other in terms of data directory. This is intentional. We don't want people accidentally running the wrong version. From the application point of view, they're mostly compatible. So if you run on Postgres 10 and you go on Postgres 11, your application will work fine. You may be in one of those very tiny corner cases where it doesn't work this way, in which case there are the release notes that explain everything that's changed. But the idea of the Postgres community is that we don't change things too much. We try to always keep compatibility. In fact, sometimes we deprecate something and we remove it after 10 years because we really don't want to disrupt people. By the time we remove it, all the people that were using that feature are already dead, so they can't complain anymore. So PostgreSQL has at least 4 security patches per year. It can be more. When an issue is discovered, if it's urgent, there is a new security release made in a few days. The release process is always very reasonable and very sensible. So it's not like, we discovered this terrible vulnerability. It's sufficient to do this to destroy your system. We will publish the upgrade next week. No, this doesn't happen. I think I remember the last time this happened, in the sense, the last time somebody discovered something sensitive was Easter 2013, the Easter Friday, to be precise. And there was a communique out from the Postgres community that said, we discovered an important security issue. We don't tell you what it is, because the packages are built-in packages. You must schedule a maintenance window next Wednesday between 2 and 3 UTC, whatever it is. At 2 UTC, we will publish the details of the security issue. And this is quite common practice when security problems are discovered, to not announce the details until there is a fix. The fix was made in 10 minutes, but you have to let all the workaround, all the sort of context, packages, distributions, derived products, all of them must prepare the new version before it's actually time to say go and upgrade. If we publish the binaries without waiting for all the binaries to be ready, somebody can actually reverse engineer the binaries and find what the problem was, and then use the problem to attack existing machines. So that was carried out very sensibly. And I don't know if you are aware of the PostgreSQL license. The PostgreSQL license is actually 20 lines, 23, I think, including empty lines. So it's less than 23. It's a very simple license that says you can do whatever you want. The University of California is not responsible. You may ask, why the University of California? Because Postgres was born in the University of California in the 80s. And that's where the BSD license comes from, Berkeley Software Distribution. Which means if you lose your data, or if you have security problems because of Postgres, you are free to go and tell it to everybody. You know this is not the case for some other software. I will not make names, because maybe the license also has a clause that you cannot make names. But there are some software where you're not allowed to publish your complaints. And I'm talking about database software. You have a license that says if you cannot publish benchmarks, you cannot publish problems or so. With Postgres, you can. So, if you have problems or if you have complaints, go and blog. But nobody blogged in that occasion. So that occasion was a serious security issue. It was found by some security researchers. They reported it in the dedicated security bug channel. That problem was fixed. Everything was handled nicely by the community, which in theory is made by volunteers, because there is no Mr. Postgres going around and paying people. In practice, they are all paid people, like me. I'm paid. As much as I like visiting Barcelona, I'm here because somebody pays me. So the community was able to handle security problems nicely. Nobody got hurt, and nobody had anything to complain about. So this is just to say that even if it's open source, people think open source is less professional. No. Well, in terms of service that you get the best, even if you don't pay for the license. Patches are easy to apply. Why they are easy to apply? Well, If they were complicated to apply, nobody would apply them, and the security issue will be left open. So you have a distinction in Postgres between minor upgrade and major upgrade. A major upgrade is where the PostgreSQL big number changes, 11, 10. In the past, it was more confusing because there were 3 numbers. So you say, which one is major? The first 2 were major. The rule is, the last one is minor, everything else is major. So if it's 3 numbers, it's the first 2. If it's 2 numbers, now it's only 2 numbers. Now we have 11.4, and next week we'll have 11.5.
Gianni,
Yeah, sure.
Okay, we are in the company, we are a lot into AWS, but in regards to cloud environments, well, we see always a delay between new Postgres versions.
Yes.
I was asking, let's say,
I also see this delay, yes.
between Mr. Postgres, let's
Wait a moment. I wonder whether everybody understands. Can you hear the question, all of you? Maybe we could have another microphone for questions, dear organizers, if any. Well, I will repeat the question in the meantime. Yeah, so you were saying that you see delay in cloud environments.
cloud providers, for example, to release, I don't know if there is some validation, but well, my question is in regards to the ways that the relationship between, let's say, Mr. Postgres that you mentioned and who doesn't exist and these cloud companies.
Okay.
Some of them are security patches that are important to apply.
Yes.
Why is this lag?
Well, some security issues cannot happen in cloud environment because the cloud environment only exposes some things. For instance, the security issue we discussed before, the one in Easter, it was a problem where if you connected to a database and you specified a malicious database name, instead of a normal database name, you created a string with zeros and strange things, that could be used to overwrite memory areas that were not supposed to be overwritten. So this cannot happen sometimes in the cloud because they have some sort of sanitization and some firewall. But yes, I agree with you. I mean, what is the relationship between Mr. Postgres that doesn't exist and the providers? Mr. Postgres releases security patches on a public place. The source code is available. Everybody can do whatever they want. The cloud providers decide whether to take these patches and update them or not. It's their responsibility. I mean, these security patches are not all urgent. Even if nothing happens, every 3 months there is a new release. So it's like a newspaper, you know. If nothing happened, they still make a newspaper and they write something like, oh, today is a nice day. But the relationship is that not all these cloud companies always are punctual in minor updates. What happens with the major updates? It's even slower. There is no security problem in not using Postgres 11. If a cloud provider only provides Postgres 10, fine, it's totally secure. It's only a question that Postgres 10 has less features and less performance than Postgres 11. If the customer of that cloud provider are happy with the less features and less performance, that's good for the cloud provider. If they're not happy, they will move to a different provider. But from the Postgres perspective, all the major releases are equally secure. When a bug is found and the fix is published, usually on the same day, different fixes for all the different releases are published. So if next week there is a security release, I am in the know, but you don't need to be in the know, you just need to read the mailing lists. There will be an upgrade for 11, 10, 9.6, 9.4, and 9.5. It will be, all these patches will be different, of course, because they go on different versions, but they will be very similar. All of them will correct some problems. Some problems only exist from Postgres 10 because they were introduced in Postgres 10. I mean, if it's a bug on partitioning was introduced in Postgres 10, cannot be in 9.6. But apart from this, every release is equally secure. And you should always apply the security patches. If you don't, you risk. I mean, if one day you go to bed and forget to lock your door, what happens? Most probably nothing. But you are at risk. And the same here. It's not like every time you don't apply, the next day the server is down. No. No, most of the time you don't have attacks. But this is very cheap and very easy. So you should always apply. Intentionally, they are independent from the main development. What does it mean? The security upgrade, the minor upgrade of Postgres 11 will not introduce any new feature, will not change the behavior of any existing feature, so that you are guaranteed that if you shut down Postgres, upgrade and restart, your application keeps working. And there is binary compatibility of the backups and of the replication.
And if the change is because the feature was developed in an insecure way?
Well, sometimes there are little things to do, like if there is a bug in an index, what they say, upgrade, restart, and then rebuild the index. If the feature was built in an insecure way, the feature is made secure. Look, Postgres has a 4-month beta period, at least, even more sometimes. And Postgres does not release unless we are sure that we want to release. Normally, the release date is September. So Postgres is like the same time we make the wine in Toscana. But sometimes there is a problem and is postponed. It's not like we release on September with bugs, no? 9.4 was released in December. There is an interesting story. 9.4 introduced JSON binary support, and there was a benchmark. I mean, we introduced JSON. We want JSON to be fast, right, with the indexes and everything. So we published the JSON, and then we found that actually it wasn't so fast. I mean, it was fast, but there was a corner case where it wasn't so fast. And the problem was that the compression algorithm, Postgres automatically compresses the data. So if you put something big, it will become small in memory and in disk because there is automatic compression. Not always compression, only if it looks good. Postgres tries to compress the first 1,000 bytes. If it shrinks enough, it compresses the rest. If not, it doesn't compress. Anyway, what happened is that the internal format of the JSON was actually a offset and then array. And the offset is like actually a sequence of increasing integers, which is the worst possible case for compression algorithms. So what happened is that if you have a big JSON, it looks impossible to compress, even if it's not. Just because the first 1,000 bytes are particularly entropic compared to the rest. So because of this, the Postgres community say, hang on a minute, we are not going to publish 9.4 with JSON and then JSON it doesn't work well. So we fix the problem, we change the internal design of JSON, we repeat beta testing and all, and we deliver on December, almost Christmas. But then it was worth, because somebody did the benchmark. I'm not going to name software because you can imagine what I'm talking about. But there is a famous database engine, not relational, that is supposed to be fast. And then there is Postgres, which I may name because I know I'm associated with Postgres. Somebody did the benchmark. They say, look, let's see if it's really true that this NoSQL is faster. They did the benchmark, and then actually it was the other way around. Postgres with the JSON was actually faster than the dedicated document engine. And why? Because it was optimized. Because we didn't release on September, we release when it's ready. And because we have a big beta test period, that in these 4 months of beta testing, somebody found a problem. So it's not like we are not better than other people. We are not more intelligent, but also not less. We are equally intelligent than other people. But we have better practices. We don't have somebody pushing releases out when they're not ready. And we don't have somebody that says, skip the testing, go live. No. There is a community, it's public, it's difficult to make these decisions, because if you make this decision, everybody will see. And when the problem happens, everybody will come to you. So in public, everybody must behave nicely, which means we did testing and we did the release whenever possible. After accumulating 3 months delay, the next year we had 1 more month, and then we managed to crawl back, and now we are around September, October again. This morning, Tomasz was talking about Postgres 12 and Postgres 13. And you may think, this is when I will retire. No, no, it's every year, the release. So Postgres 12 is this year in September, October, around that. Postgres 13 is 2020. Postgres 14 will be 2021. It doesn't have to be. Sometimes it can be a little more, but the plan is to have a yearly release cycle with all the... And the community is working like this since, I don't know, I joined the Postgres community more than 10 years ago. So I've seen more than 10 releases. So it works. Note this, even if the life is 5 years, it can actually be that you pay somebody to help you longer. I'll make the example of my company. We have 2 years more. So if you run 9.4, community will stop support in December this year, and we will stop support in 2 years more. It doesn't mean you can use the old version and it's good. No, it means you should use the new one. But if you had some problems, if you have no budget, if anything happened, you will not be outside of support. The cost is to pay people that are available to help you backpatch problems that have not been backpatched. When a bug is solved, it takes a little work to apply the same patch to all the versions at the same time. So for this extra work, you pay the support contract. This is an interesting story. How many of you know what this is?
Under technology?
No, this, a STIG. Yes, but you know where it comes? This is not you and me. This is the United States. So the Department of Defense of the United States has these documents, STIG. They are documents where they say, look, if you want to make a secure implementation of this thing, you have to do this way. Because it's a big organization, and they don't, it doesn't work that they say, when you need to install Postgres, call Andrew. No. It has to be, when you need to install Postgres, open the following document. So they made a document in how to implement PostgreSQL securely in January 2017. And that was the first open source database that the Department of Defense of the US considered worth a STIG. It means that internally, when they deploy Postgres securely, they follow these guidelines. To me, it also means that Postgres is probably interesting enough. I didn't get confirmation from the US president about Postgres. I tried to write to say, can Postgres? And they didn't reply to me. But, no, I'm joking, I didn't write. But the thing is, it's interesting that Postgres is supposed to be good for such an organization. We have many customers in finance, military, in these places here. But this is not a customer. It's a public act. So you don't have to trust me. You just go in the repository and find. All right, so this was the introduction. We didn't talk much about security. We talked about the environment. And now we'll talk about something related to security. Postgres has a role-based security, okay? So you define roles. A user is a role, but also you have a role which is not a user. So for every person or every application, you have a role. And then you define a role for every function, like web application, administration, whatever. I don't know how many of you, probably nobody, attended the webinar from my colleague Boris Mejias. He did a webinar on security some months ago. But he made an example of a web application where there's the users, the application, and there is the administrator, there is the approver, the supervisor that approves, and then there is a reviewer, which is somebody like a supervisor but can only watch and not approve. And then there is this administrator, which can do everything. Okay. So you create users or roles, whatever you need, and then you grant roles to other roles. So roles is like some sort of hierarchy. I am Gianni. I can have the role of web developer. I can have the role of system administrator. I can have the role of application 5. When I connect, I can become that role and do those things. Okay. You use the standard grant and revoke commands. I think you know them already because they're standard SQL, not only Postgres. In fact, Postgres follows the standard quite quickly, quite strictly. And you can create a self-documenting privilege structure because you don't have to explain why I give Gianni the privilege to read from this table. You give Gianni the privilege to be a DBA, and then you give the DBA the privilege to read from this table. It doesn't need an explanation. It's clear why. Gianni gets to read the table because Gianni is a DBA. The moment Gianni is no longer a DBA, you revoke DBA from Gianni. You don't go to 50 tables and revoke Gianni once for each table. So this way, it's easier to manage, but also self-documenting. So this is an example. You create a table. Well, this is a test table. When you do this command, you revoke from the public. The public is not a real user. It means everybody. You know? There is this role in SQL databases where public represents any possible user. Here we are effectively saying that the table is only accessible to those that have been explicitly approved. Then we create a role, and we say that this role can do everything on this table. So the role can read from the table, can insert new rows, can change some rows, can delete other rows. And then we have a user called Alice, or Alice. Maybe in Spanish is Alice. I don't know. In Italian is Alice. Spanish, I don't know. And then we give the role R to Alice. Well, I suppose I should decide what pronunciation. Well, let's call it Alice, because I'm speaking English. This way, we don't specify what Alice can do. We specify that Alice can become R. And then we did say before that R can use the table T. When we create a user Bob, the user Bob cannot do anything initially because he's member of the public, but to be member of the public, you cannot use T because the public cannot do anything on T. Of course, you can make more complicated things, but you have a separation between what is called identity management and access management. I think you hear these words continuously in the workplace. Identity management is when Alice is a given person, and access management is when R is allowed to do things on a table. So both of these things can be done with PostgreSQL roles. Now, is this enough? Well, of course, you have a table. If the table is big, you may not be satisfied by saying yes or no. Maybe you say, look, Alice, you can read the table, but you can only read some information. Maybe Alice is Italian, so she's Alice, and she should only read about Italian customers. And so you need a thing which is called row-level security. In Postgres, there is a possibility to attach to every table a security policy. And the security policy means that that table has a rule that if you are a given user, for every row, we apply the rule. If the rule fails, you don't even see the row. So you definitely cannot do anything there. Okay? So we can have privilege that go in an horizontal way rather than going in a vertical way. You have the possibility to use session information, like there is a variable called current user. Current user means who are you? But who are you is a bit like you can put a mask on your head and become somebody else. So Alice can become R because she has the role R. So she can say, look, now I'm a DBA, so I can do the things that the DBA can do. And now I've become a developer. Now I can do the things that the developer can do. And the session user is the user that you log in. That you cannot change. That is your DNA. So if you want to make a rule that says this task is only allowed to people that log in as Gianni, then yes, you have to use session user. If you want to have a task that says this is only available to people that are DBA, then you can use current user if you want. Normally, you cannot log in as DBA. I mean, of course, you can configure DBA as a user, but this is a mistake. It's not an error because you will not get an error from Postgres, but it's a mistake because you should not have anonymous users. All the security policies in the world say that every time somebody does something, it has to be individual accounts, not anonymous accounts. Otherwise, you will see that every time there is something wrong, it's done by somebody anonymous, of course. Nobody owns mistakes. So the policy can specify, depending on the contents of the row, if the user can do something or not. However, there are some users that are more equal than others, like super users. A super user can always do everything in Postgres. So if you have two super users, they must trust each other. Because if one super user does something, that super user can also cancel all the traces. So, super user is like root or administrator in a machine, has to be totally responsible for everything. So the policies is something that you create and you put the or. So if I have 5 policies, I say I can see the rows with the same name as me, or I can see the rows with the same country as my country, or I can see the rows where public is true, like maybe there is a column that says public. These are all policies. As long as I satisfy one, I go through. But it's also possible to have a restrictive policy, which means they have to be true always, like end, So this is just to say that there is this policy mechanism in Postgres which is very strict and allows you to build a complex database. So let me now make a little exercise for you. So this is exercise 1. Oh. I have to unplug the... There you go. You can see, but it's not very big. Let's make it bigger. Now it's more readable. Okay, so we want now to make an example of a security policy on a table. Okay, so this is quite simple table. There are 3 columns. One column is the username. The other column is the amount, and then there is the approval. And also we want to put a date, probably. This means that when you insert a row, if you don't specify the date, you get the date of today. Okay. So let's actually use it. Now, one thing about Postgres. Do you know that Postgres has a transactional DDL? Which means you can roll back everything, practically. We will use this feature to work on this example here, because we don't want to create the table 5 times, because we will get an error. So you know what we do? We start a transaction, we do whatever we want, and then we roll back. So we see what happens, but then we roll back, so we can keep repeating the same script over and over and see the result. So the script at the moment doesn't do anything special. It just runs the create table, okay, and then it rolls back. Now we want to create some data in this table. So we can do some experiments on this data. The best way to insert data on Postgres is to use the copy command. But we can also use insert, why not? Let's say that I spend 100 euro, and initially it's not approved, okay? Now, here, I am creating the table. So I'm an owner of the table, so I can do all the things on the table. But when I revoke all on the table, I don't allow other people to do anything. The other thing is that I'm a super user. You can see here. This hash means super user, which means whatever I do, it's allowed. So this is for my convenience on my laptop. I'm super user, of course, because I also have a password, as you can guess, on my laptop. So when I log in, it's secure already. But in a production environment, you normally are not super user. You only become when you have to do things. So this is an example that will not do much of a difference to me, but we can obviously become somebody else. So we can create a user Alice. She's not a super user. And I can become Alice. Voila. Now, I am no longer Gianni. This Gianni here is the name of the database. So it's not the name of the person. I also have a database called Gianni, so I put all the garbage there, and when I want to clean my laptop, I just drop the Gianni database. So now, if I try to do, let me reload our script. So what we do here, we create the table, we revoke the privilege, and we put one row, okay? So now, what do you think happens now?
Give you an error.
I get an error. Where I get the error? Here. And why I get the error in the insert? Because I'm not, I'm Alice, which is not allowed to do anything. You see? Okay, so now I'm no longer, I'm still Gianni here, okay? And now I want to create a policy that specifies that you can only see things if it's your rows. So if this is an expense for Alice, okay, Alice can see but not Bob. So let me also create a user Bob. Now we have Alice and Bob, as in 1,000 books. There's always Alice and Bob. Have you ever met a couple who's called Alice and Bob? I never, because I think I will, what? No, sorry. So what we want now, we have Bob. I should probably watch here instead of watching there. So I write better. And then when it does select, so what I want to happen here, after I create my policy, which I haven't created yet, I want to happen that Bob is not allowed to see the row. Now, Bob at the moment will get error. Why? Because Bob is not allowed even to access the table. But what we want to...
What's the tool that you're using?
This tool?
PGL?
No, this is an editor. It's called Emacs.
Okay, because I saw SQL there.
Yeah, I mean, it's one of the editors that try to make life easier by... Look, all the colors. It's easy. If you make a mistake, you see it. Anyway, what happens now is that we want... to allow Alice and Bob to select an insert row, okay? And at this point, Alice will be allowed to insert. And then Bob, at this point, is allowed to read, which is, it is coherent with what we wrote, but it's not the example we want to make. In the example that we want to make, and I think probably this example is more readable if I move it to the side.
But Bob can write.
Yeah, this is correct. It's just not what we want to do. We want to do an example where Alice handles her own expenses and Bob can handle his own expenses, and they cannot see each other's expenses. So Bob cannot go to Alice and say, what were you doing in Barcelona? Because Bob will not know that there is an expense ticket for Barcelona. So how do you do that? You create a thing which is called policy, okay? And it's a thing that you do using alter table command. So the exact syntax is like this. Where is it? One moment. I have the example, but I have the wrong window open. Yes. So you have the first thing you have to do. You have to do this. Why? Because row-level security is expensive in the sense, because every time everybody does a query on a table, another query runs to find if the person can do the query. So you actually enable or disable the row-level security on the table. And then after that, you can say, OK, if there is a row security enabled, which is a flag in the metadata, then every time somebody accesses, there's going to be this row security check. You will not need row security on all the tables in your database, because it's not so important. Only some of the database table will require a policy. So let me now create policy. Okay. For all, this is like grant, no? When you grant, select, insert, update, and delete. So the syntax is what is the name? Uname. Sorry, obviously. On expenses, obviously. What did I write wrong? Sorry. Yeah, I forgot the name of the policy. You need to name the policy because you need to be able to delete the policy if needed.
It doesn't allow to enable rows.
Let me see. Enable row level security, yeah, sorry. Voila. You see? What happens now is that Bob is now unable to even see the row. So it doesn't give error like it will give if you didn't find the row. It gives empty because Bob is not allowed to see that there is a row. Because in a sense, if you were able to see the row and you were not able to do anything with it, you will discover information. So the most secure way to hide information is to actually not even notice that there is a row. Now let's see that this is actually working by changing the role to Alice. So let's do this.
So does this add like an extra where clause to all?
In a sense, yes. Now I'm using so, well, sorry. Here it is. So in effect, the policy is effectively an extra clause, but there is a little bit of extra logic because you can have before and after the modification. So you can have two different kind of policies. Here we use using only, which means before the change. So here you can effectively filter what rows you can see. But you can also have a policy that says you are forbidden to change a row if the final result is not what you want. So you can have a rule called using and the rule called check. The using is before and the check is after. So this way you can forbid an update. Or you can allow an update only in a certain way. Okay? So this is the main difference between these two examples. And let's now show the example like it is now. All right. So you can see, and let me make it a little bit smaller so we can find everything in a single screen. What we do here, we create a table, okay, with the rows. We put one row with the name Alice, 100, false. We enable the row level security, which is disabled by default. We create a policy on the table for every possible operation, select, insert, update, and delete. It applies to everybody. And then the policy can see, allows using only the rows where the current user is equal to the column called username. Then we become Bob. Becoming Bob means that we dress like Bob. So we are current user Bob, but session user we are still ourselves because that's our login. When we are Bob, we try to read and we don't see anything. Then we dress like Alice. We try to read and we see the row from Alice, from exactly the same table. In the past, this wasn't really possible. You could emulate by having multiple tables and then having a like partition table in a sense. You have a table which actually has a lot of tables, and every table you will give permissions or not. But then you will get error. You will not get empty. So this is really an important feature for security. And the morale of this approach is that you push authentication to the database, okay? So you are the user. You don't handle these things in the application. You just pass it through to the database. What is the advantage of doing this?
Even if you forget, it still works. Even if you forget to check for permissions.
Very good. First of all, you must not document anything. When your boss comes to you and say, how's it working? You say, RTFM. Well, maybe you say RTM because it's your boss, but you don't have to document. Yeah.
And what about the performance considerations? So, as I understand, for each row, you need to evaluate this function. So, basically, do we need to have additional index for the predicate, or how the things works under the hood?
Well, in this case, it doesn't do two queries. What it does, it changes the query here, adding an extra condition to the query. Well,
For each query, these should be additional search conditions.
I think if you need to filter based on a column, you need to put an index in general because it's a good practice. My point is that this is not an extra performance because you actually add one more condition to a query. When you add one more condition, the query becomes faster. Because if the query without the condition will read even more. So it's not 2 steps. I describe it as 2 steps because logically it's easy to understand. But the way it is implemented is the same step with an extra condition. Because the database is a declarative engine which normally handles filtering by itself, then it's funny. It's a bit like reflection in Java, introspection. You have an engine whose job is to filter data. So this job is also applied to implement its own security rules.
Pushed back to query optimizer. So it doesn't apply to each row returned. It's pushed to the optimizer.
Yes, it's able to filter. Yes, of course. It doesn't. It does it in the Postgres way. Yeah.
And what about check?
Check is applied after. So here there is no after. It's a select. But if you do an update, check is a rule. I mean, we don't have time for check because in the whole 1 hour and 45 minutes we want to touch all the topics. But the idea is that you can specify another policy where approval can only be done by a supervisor, let's say. And you can specify that when Alice inserts a row, she can only insert with approval false. So she cannot put expenses already approved. And she cannot update her own expenses. So the check policy will be that you have with check, false. With check, approval equal false. And this is only relevant, of course, when there is a before and a after, which is only for updates and inserts. For delete, the after is very simple. There is no after at all.
I understand that both can insert rows only with your name both, right? Both cannot insert a row with your name Alice.
Well, yeah. At the moment, you can. Because this is per for select. But if you add that policy, you will not be allowed to, yes. I mean, this is an example of an exercise. If you really want to implement expenses system, you put 3 or 4 policies. A person can only put expenses for themselves. A person cannot approve their own expenses, and so on. You have to create a policy for every rule. What is the advantage from this to make your own code? This is declarative, so it's self-documented. This is easy to audit. You go in the catalog, you find the list of all the policies, and so this is, if you dump those catalog table, you get the description of all the security rules on your database. If you implement it yourself in application space, you never know. Maybe there is a bug. You take responsibility for bugs. This way, you don't take responsibility for bugs. You have a declaration. You don't have an implementation. Do you think it's hidden this way? I mean, this way you publish your logic.
Basically, they don't have so much access to the database that they prefer to look into the code.
Well, let me say something. This is something that the developers should write. In my mind, the developer decides the database model. Not the DBA doesn't.
Yes, it should be written by the developers, but you see, one developer knows how the things work, another don't know. So the developer who was written just got fired or something like this, and then all this logic
Sure.
is somewhere.
But this is documented. And it's a SQL standard, and it's stable. Code written 10 years ago still runs. Have you tried to run code written 10 years ago in other languages? Sometimes it's challenging. This is, I mean, you can say I prefer a different language. You can say I prefer many other things. But definitely, if I wanted to look at how this, let's say that I forgot. Oh, I forgot what this policy is. How can I see what it means? Difficult. Let me open the documentation. Actually, I can even go here and do \h, but let me go to the real documentation, okay? So I have PostgreSQL.org documentation. Postgres 11. Reference, SQL commands.
When was this implemented? The row-level security?
9.6, I think. I don't know. Anyway, some versions ago. So create policy. Here it is. So, voila. Here is the syntax. This is the documentation of Postgres. It's part of the source code of Postgres. It's compiled every time there is a commit. So if there is anything wrong here, it's a Postgres bug that will be fixed, as soon as practical. So it's never separate, it's never late from the code. So this is the description. And you find here the syntax, I forgot to specify the name of the policy before. That's why I never think. But every object in SQL must have a name. Otherwise, how can you drop it? You cannot point your finger. You need to indicate it. So here is the explanation, all the policy. The with check expression is enforced after the before triggers are fired. So this is actually the specification how it works. So if you have a doubt, you can verify here. The description of all the parameters, all the various policies, select, insert, update, delete, all the table, what works in what way, so all documented fully. And what happens when you apply multiple policies? Look, the restrictive policies have and then the permissive ones have or, and so on. Various notes, and compatibility. This is not the SQL standard, actually. It's a PostgreSQL extension, so there is no create policy command in the SQL standard. And everything else. And, this is, to me, this is quite stable. The work we do with our customers and also sometimes with outside of customers shows that there is very little need to change code written before. In fact, nobody ever rewrites code because they don't have time. If it works, if ain't broke, don't fix it. And so it's quite good to be able to document. You can see the documentation is also version sensitive. So if you have something that was working in Postgres 9.1, you can click 9.1 and you will. Here it only shows up to 9.5 because the create policy was introduced in 9.5. Otherwise it will show. But if you go on create table, you will see this page going back a long time. Okay, so this was an example of security policies, which sort of concludes the discussion about privilege. Now, because it is 3:30, I suggest we take like a 10-minute break and restart at 3:40 with the second part of the seminar, which is no longer about roles. It's about a different part of security, about application security, application developer, and so on. Cool. Any questions? I guess not. Otherwise, I will ask them.
Can you use a function?
Yes, but it must be an immutable function. In Postgres, there are volatility classes, which means a function which is immutable with the same input always return the same output, like the square root.
Not now, for example, not current time or yeah.
Well, a function which is stable, it's not immutable, but it is immutable inside the same snapshot, which means it reads a table. So if you read twice in the same query, you get twice the same result because you have a snapshot for consistency. And then there is a third class, is volatile. A volatile function is not guaranteed to return the same result, whatever. So for instance, random is volatile, but also clock timestamp is volatile. Current timestamp is stable because it's the time of the statement, not the time of the clock. So yes, you can use functions as long as the functions are good enough. Can you use a function in an index? Yes, you can use a function in an index if the function is immutable. You're not allowed to put in an index something which is not immutable because obviously you compute it now and you compute it later is different. So an index will be wrong. Okay, so you can imagine that the example that we did before, where you have a table and decide the policies on the rows of that individual table, can also be applied to other things that are not table. Okay, we saw an example row-based. We didn't show examples with schemas or databases or functions, but many objects in Postgres have privileges, and the privileges are different depending on the object. For a function, you don't have a select, insert, update privilege. You have execute privilege. The database, you have a privilege to connect or not. So different objects have different privilege, and you can grant or revoke this privilege. So you have a totally declarative description of the state of the privilege in your database, which is good because then you can audit it. We are subject to auditing requirements. Sometimes the law, sometimes our boss, sometimes common sense. You want to know if somebody broke into your database, and you also want to know if somebody, how many times something happened, if there is possibility that something else happens, and so on. If you have an algorithm that you create yourself, and then you go and inspect, how easy it is to prove that your algorithm is safe? It's difficult. You need another developer, equally good, if not more, to look at the code and do some sort of Turing machine analysis and see that there is never a mistake. This way, the code is separated from the logic. Postgres is written in C. Postgres inside has its own code, of course. But then it implements a language, and the language allows you to describe the rules, and then you can audit the rules and see that the rule is good. Then, of course, it's always possible that there is a bug in the code, but the code is public. It's not your own code that you wrote and nobody else can read, or very few people can read. This is the Postgres code, which is thousands of people. It's public from the 80s. So, well, from 1995, actually, not the 80s, but still a long time. I mean, it's evolved, for sure, but there is a big public discussion on the PostgreSQL code. So a probability of a bug in your code is higher than the probability of a bug in the Postgres code. Not because of you. You are not less intelligent or less skilled, but you are one person, and there is not continuously review on your code. So the declarative approach is superior because the rules are written in a language that can be audited more easily because it's not an imperative language. And the code is written in a public way, which is always the same, and so it can be scrutinized more. Okay? So you have a system of rules for users, for rows, for privilege. You have a system of rules that discipline everything. Okay? Still, auditing is not only that. Sometimes you have additional obligations for auditing. So your company wants to check who connects, who did that, who did what. And so in this set of slides here, I will review what instruments you have for auditing in Postgres. So you want to log what happens, and you want to log it in an immutable way. Okay? You don't want to log things in a way that somebody can go there and cancel when they do something that doesn't like. This is also why you shouldn't. You should trust a lot the super user, because the super user, at least if you log into another table, the super user can always go in that table and delete rows, and you will not know. If you put triggers on that table, the super user can disable trigger, delete the rows, and re-enable them. So yes, there is a way to log things that the super user will be spotted, but it's much more complicated. So the audit log must be reliable, and it must be inspectable. So the best format for the audit log will be a list of actions. Who did what, when, on what objects. And of course, a possibility to do queries on it, to read, but also to analyze, to do select, and everything. If your audit log is something that you need to watch every week or every month, you will have a process to do that. But if you need to query every minute, and you need to find breaches every minute, then you need to think about a system where it's easy to do the query. You can do application level logging. This is something that is possible. You simply put in the application the possibility to read things, okay? And this is, in a sense, easy to implement, because if you are an application developer, you can effectively develop your application this way. But in another sense, it's complicated because if you have 5 applications and one of them doesn't do the auditing completely, you don't cover. In other words, if you put the auditing at the end, you are sure that you capture everything. Normally, the auditing, it's only useful if you capture everything. If you have a bank account and the bank says, I promise that I will not lose your money between Monday and Friday. Not very good, because they can lose the money in the weekend. It's important, this is the big limit, that if one of the applications is not good, that application can do the wrong things, and then you will not know. You look at the log, you find nothing wrong, but the wrong happened without logs. This is a positive, that the application is able to know why. So instead of seeing that you insert one row in a table, you will see creating new access request for website ABC. So you can see the motivation, not only the effect. And you can also put extra information, who is the application user, something that's not available in the database. Another possibility is to put the auditing on the database. So this way you put a trigger on tables, and what does the trigger do? The trigger fires every time somebody makes a given operation on a table. So if you insert a row, there is a trigger before insert, or there is even a trigger after insert. Maybe you want to audit what after it happens or before. It's your choice. The limitation is that this doesn't work for things different from this tree. If you do a select, the trigger will not audit anything, because the trigger only fires when you have a data change. This is, however, easy, because if you put it in the database, you have like a lot of applications working with the same database. This works smooth, because the application doesn't even know that there is auditing enabled, and so you don't need to worry about that. So this is an example. This is the PostgreSQL procedural language. This is a function, trigger function. What happens is that when this trigger runs, it inserts a row in the table called audit log. And this row will have this value, and this list of values. Look, new is the row being inserted. Dot star means that the single value is expanded in many values, one for each column of the table. So if your table has 10 columns, the audit log will have 12. We will have the timestamp, the username, and the other 10 columns. Okay?
Is the expansion secure?
Yes, it is. This you can see here. It's a keyword.
It's parameterized. I mean.
Yeah, it's not Bobby tables. If you want to know that, it doesn't. It doesn't expand the query and then parse. In other words, this is secure because PGSQL is a language that includes the SQL as part of its own syntax. So this is parsed before execution. This is identified as a given record variable expanded in its components. Then the query runs, and then the row is evaluated. The new will have 10 components. The components are split and put in these 10 slots. So there is no possibility to put a quote, comma, quote to emulate the start of another string. So it's SQL injection safe. How many of you know what is SQL injection? Okay, so this is not at risk of SQL injection. The trigger allows some flexibility. You can ignore certain changes. For instance, you can do auditing that only audits certain things. So you don't want to audit normal usage, you want to audit special usage, like when the transactions are above 1,000 euro, or when user is not in the office but from home, and all these kind of things. And the other possibility is that you don't need to use a table with 12 columns. You can have a table with 3 columns, because you can convert these to JSON. So your audit will be timestamp, user, JSON. What is the advantage of this? Because then you will have 4 columns: timestamp, user, table name, and JSON. The advantage is that if you have 1,000 tables, you don't have 1,000 audit tables. You have a single audit table with all the audit information together. And this is like in this example here. Here you have actually 5. The table audit JSON B doesn't have the columns like the normal table. It has the timestamp, the username, text, the table name, op is the operation, so insert, update, or delete. And then toJSONB is a function that takes a SQL record and converts into a JSON value. B is a JSON binary, or better, depending on what you believe. You know what is the B in B3? No, nobody knows. Well, if you go in Wikipedia, they don't know, so probably nobody knows. Because it's so old that they don't remember if it was Bell, or if it was binary, or if it's the surname of one of the 2 people that were working on it. It's just B3. It's older than me. You know, I'm younger than B3. Can you believe it? I don't believe it myself, but it seems true. You know? Anyway, what is this function here? Every time, so this is just a trigger function. By itself, it doesn't do anything. When you attach this trigger function to a table like this is after insert or update. So every time there is an insert or an update, after this, you get 1 extra row in the audit log for every row, for each row. So if your insert puts 10 rows, this gets 10 entries in the log. If your update touch 0 row, you get nothing, because there's nothing to log. Okay. Now, for completeness, I can mention that you can put everything in a trigger. In Postgres, trigger functions can be in this language, but you can use Python, Perl, Java, C, Shell. You can use everything you want, because every time somebody wants to use a language, they just have to write a plugin for that language, which is not so difficult. The meaning is that you can put a trigger that when you do an insert on a table, it actually fires something else outside of a database. Send an email, open a VPN, push something to a REST interface.
Print on the printer.
What?
Print on the printer.
Yes, if you can have a paper database, I suppose. Insert into printer, eh? Zzz. Yeah, okay. Well, it's a lot of things you can do, but also don't do useless things. You must think that everything you do, you have to support. But still, it's very useful sometimes to have to consider the database as some sort of center that is able to relate with all the different external services. And I will mention a couple of more things. Here we mentioned send data over network. Logical decoding is a very important feature of Postgres. It was implemented now 5 years ago in 9.4. It is the backbone of logical replication, which is itself the backbone of multi-master for Postgres. It works this way. When you do a transaction, you produce transaction log. This is like every database in the world. They have transaction log because in the event of a crash, you can recover quickly and so on. The transaction log can be decoded in a logical format. So when you write like an insert, you get a line that says, insert this and this. And when you get an update, you get update this and this. But it's not the same query that you write. It's a row change. So if you have one update statement that produces 20 rows, you update it. You will get 20 update log records. So these can also be used for auditing. Because Postgres logical decoding has a plugin interface. So you effectively plug the decoding plugin into Postgres, and then every time there is a commit, Postgres feeds the rows to the plugin. you make the plugin, you decide what you do. You can use the plugin for sending to a web service. You can have a plugin that push to Kafka. Well, actually, PGLogical 3 can push to Kafka or to RabbitMQ. You can have a plugin that push to another database system different from Postgres. You can, this is another way to do auditing. The limit of this, you only audit committed transactions because rollback transactions do not even get decoded.
So if you get an error, for example, if you don't have the permissions?
That's not logged because it never gets to the wall. It's just, it gets to the wall, but the commit record doesn't get. So there is no decoding of rollback. And this is also a limit of triggers. If you have somebody that does something bad, insert here, select to read some information, and then roll back. That never leaves a trace. Of course, you can create an audit trigger that instead of inserting into a table, it push to Kafka. This leaves a trace because you cannot roll back Kafka. I suppose this is like a hardware shop where you buy hammers and nails, and then it's your responsibility to build a house that's stable rather than to build a wobbly one. But security, it's always a question of using the tools in the right way. It's not so, you cannot say, you know what, I installed the security package and then I'm safe. No. Security is software together with practices. You need the good software because the software with holes is not good, it's not secure, but also you need to use it in the right way. And so what I'm doing here, I'm sort of making a presentation examples that show you that there exist some tools, and then you can use them in the right way. So, PG Audit, what is this? PG Audit is an extension that effectively logs things happening in your server to a format which is a bit like CSV. So it's the attempt of PG Audit is to improve the logging capabilities of Postgres. Alone, it cannot do everything because an extension is not allowed to do everything. It can do many things, but not everything. And also, an extension is effectively a C function or a set of C functions that you attach to objects. Some of them, you can hook them at particular points of Postgres. So every time there is a query, the query will have parsing, planning, execution. And then you can, of course, you can put, there are hooks that are normally empty. If you define something, you can put a piece of code which runs there and then returns control to Postgres. So you can do many things, but this is something that it's a product that you can download. It's open source, but if you want to modify it or improve it, you have to be able to go deep. You have to be a good swimmer. So these will list the object that you access. And for instance, when you select a view, you actually see the tables, which is interesting. And if you write a query without specifying schema names, this one this one actually will log the schema name because you see you have you can log these that you also were able to log with the standard trigger solution, but you can also log the selector. These will normally not be possible. And you see there is a number of things that can be logged. When you do an audit, some of these things are very important, right? These are important. Also, this is important, or alter table, it's important. So all these things here will not be captured by the logical decoding, because the logical decoding only works for DML, okay? So audit must be as wide as possible, and some of the nice tools that we've seen so far, they have the defect that they can only audit a given section of SQL statements. So this is just an example. You can see how many different things are logged. And it's called PG Audit. It was a project, we also contributed to that project some years ago. The idea was to try as much as possible to create a tool to be able to match legal requirements. Some of our customers are banking. I mean, when it comes to banking, you don't go there and say, I do auditing, trust me, I'm good. No, there is a specification, it's a document with hundreds of pages, and it says a list of requirements. Every requirement has a number. They ask you, are you compliant with requirement 57? If you are compliant, 57 will say, I don't remember the exact number, but password must be changed at least different from the last 6 passwords. All these rules are specified clearly. So it's not like auditing means I'm good. Auditing means that there is a long checklist and I tick all the boxes, which is something that these tools, they try to go near. It's a big amount of work, but it's very important because A, it is really secure, and B, it's the only way you can even enter certain customers or certain pieces of work. I mean, I don't know exactly what you do because I don't know individually all the things that you do, but if any of you works for a service provider, if you don't have the certification, you cannot even apply for work, let alone win the contract. So this is very important also because it's a product. I recommend using products rather than creating things yourself because a product is a specific thing that you can refer to. If it is a product, it will have a version number and it will have some sort of place where it exists. So it's possible to say PG Audit version 1.5 is compliant with 20 things because it exists. You cannot say my script is compliant because your script can change over time. It's difficult to certify something like that. And also when you use a product, you sort of delegate responsibility. You take responsibility for choosing the product, but it's much easier to improve a product rather than to improve something which is not public. Cool. So this was about auditing. If you have questions about auditing, you're welcome to ask them even outside of this seminar. But at this point, I will just move to another topic because security is many things, and I don't want to leave too many of them untouched. Authentication. This is quite an important and simple topic, but at the same time, not so simple. Postgres has a good way to authenticate users. When you connect to Postgres, there are many levels. The level number, let's say 2, is this one here. You connect, and then Postgres has a set of rules deciding what to do if you request access. So depending on your connection attempt, it can be TCP/IP or via a socket. The socket is simply a file, so you can access. And the socket has the limitation, it only works on the same node. So you cannot access from here to another node using a socket. You need TCP/IP. Then you specify database name. In Postgres, you always specify database name when you try to connect. You cannot connect without database. If you don't need to read the database, well, specify one database. Or Postgres. I mean, many people do not use the database called Postgres. This is created when you install initially Postgres, and they prefer to leave it empty because it's supposed to be something for administration. But it doesn't matter. You can use it for production data. We know also people that have production stuff in Postgres. Then you have a username because you will be trying to access with the username. Anonymous access is no longer a thing since many decades, And then, depending, if you are connecting in TCP/IP, you will have an incoming IP address. So also this is part of the rule. And then there will be this is the reply. So if an attempt of this kind to this database from this user, from this address range comes, what do? I do method. Method is, what kind of authentication method you have. This is an example of rules, okay? First rule, Local, which means Unix sockets. All, which means every database. Postgres, which means Postgres user. IP address, nothing, because it's local, so there's no IP. You are from the same machine, connecting via file. Peer, what does it mean? This is the authentication method. It means if I am operating system user Gianni and I try to access with database user Gianni, then the database says, all right, this is Gianni. If it's Gianni on the operating system, we accept it to be good for Gianni in the database. It's a bit like single sign-on. If the operating system name is different from the database name, we reject. But then look, this is a rule. For every user and database TCP/IP, from localhost, we require a password encrypted in MD5. I mean, when I say encrypted in MD5, it's like if I say MD5 is not an encryption, it's just a little hash, but don't consider it safe. Yeah, we have this. This is better. Anyway, look, this is the localhost in IPv6. This is now a range. Every connection to database SafeDB coming from whatever user in this range is rejected. So this is a blacklist stopping every connection to that database from that range. Maybe this is not a range that we trust, and this is a database that we want to keep safe. On the other hand, my database, when anybody tries to connect to my database, from this IP, we trust. This is don't use it. It's an example of something bad, like when they do the security seminars on smoking and they put the people in the hospital bed. So that's the same kind of thing. Don't do trust, because trust means don't check password, don't check identity, just accept the connection. And finally, look, for anybody in this range here, this is 16, so 10, 8, whatever. Anybody use this modern authentication method, and if this succeeds, let in. If not, close out. Okay. There are special rules that you can specify here to request SSL or to make a rule that only works without SSL. So you can, for instance, reject no SSL and only accept SSL if you want. So what is this? This is some sort of firewall, but it's the Postgres firewall. And again, this is declarative, and so it can be audited. And in modern auditing, you can query Postgres, and there is a catalog view with the list of all the rules. So it's easy to programmatically verify that some people cannot do anything bad. In fact, when we do a security audit, we run a series of queries, get the information, and then we apply filters to the queries, and then in the end, we can programmatically find holes in the database of our customers. So and then, of course, we tell them and help them to close the holes. So this is like, questions you should ask yourself, And depending on the answer, common sense should suggest what to do after. Also look, remember that you must only allow the right users to connect. Principle of last authorization, in a sense. Do not open too much. Close everything and only open what you need, like in normal life, really. If you want to be secure, you will do this. And in particular, super users must not be used except when necessary. So not use super users for application, but also for deploy, nothing. Only use the super user really when there is a need to provision a new machine to do some sort of low-level configuration. Postgres, in fact, has a dematerialization of privilege project. Over time, we are removing the need for super users. It used to be the case that in order to do replication, you need to be a super user, not anymore. There is a special privilege called replication. It used to be the case that to read statistics, you need to be a super user because you get pieces of data. Not anymore. Now there is a privilege specifically for reading statistics. There will be a day where the only reason you need a super user is to give privilege to other users. And then every operations Every operational action will have to be a specific non-super-user privilege. Here is just to mention that SCRAM is good, MD5 is and password. This is even worse because it's like MD5 or without the MD5. So you send the password in clear for authentication. Very bad. Don't do that.
Does it store it in clear text as well?
Well, store is stored in the data directory together with the rest of the data. So, I mean, but what I mean here, the client will send the password in clear text and then Postgres will, this is not really good. Anyway, even if you don't understand how it works, which you don't need, use this and it will work well. Of course, you can also use a separate password engine. Postgres doesn't need to store the password. You can also use Kerberos or what is other services. Okay. Yeah, this is SCRAM, not in particular. And let me now make a last mention before we end.
Can you use Quant certificates for SSL?
Yes, you can authenticate. Yeah, you can authenticate with SSL certificate. Yes, this is possible. And let me show the last picture before we end, because it's the end of the seminar. This is the last picture. I cannot make a security seminar without showing Bobby tables, really. What is this? This is an example of the kind of problems that can happen, If you replace the name if you insert in a table a name like this, and if your query is built by concatenating strings, this string here will look like end of a string. This looks like the end of the insert. So when you do insert into values, parenthesis, quote, then you put the string here, Robert, then there is a quote, then there is a parenthesis, semicolon, and then there is drop table students, and then semicolon, and then there is comment so that the remaining characters are ignored. So this way they have injected drop table students inside your query. So this is why it's called the SQL injection. Never, ever build your queries by concatenating strings. As the mom says here, I hope you've learned to sanitize your database inputs. This is obviously not my humor. It's from here. It's legal to quote it as long as I put this. I check the terms before the conference. So remember that I think what is the mistake here? Here the mistake is that you believe that people will do what you want. It's like when you cross the road, you see there is nobody. Yeah, it's red, but there is nobody. I crossed the road. The other people must stop because it's red for them, And no, if you cross the road when it's red, you cannot assume that the other people stop at the red. So security is half technology and half procedure. So I recommend that you always assume the worst when it comes to security, and so it's a question of respecting practices and respecting the rules. Cool. So that was my seminar. And if you have questions, but you already asked questions already. And then otherwise, thank you for your attention.